So these guides, along with good process, all of a sudden, high performance is easy.
You know, this rethink towards net zero is rethinking a lot of the traditional building enclosure assemblies and building them better.
I get excited, but I also get depressed. I'm depressed because I'm old. And if I was younger, I would embrace this opportunity for this change. I see the young builders, and to me, I get excited for them.
Hey,
How you doing?
Okay, I'm going to walk you through Appendix B, which is selecting exterior insulation for split insulated wood frame walls. This is an appendix to the LEEP Net Zero Ready Wall Design Guides, and it covers the rationale and design decisions made for selecting vapor control with different types of exterior insulation. So if you have questions about, do I need a vapor barrier? What should my vapor barrier be with different types of exterior insulation? Or how much exterior insulation do I need? This is the appendix for you. Okay, so the way this works is you're going to have an R value target you need depending on your energy model. That could be based on net zero ready, could be depending on what you're building to today. You're going to calculate your effective R value. You got your target, you calculate the R value to match that. And so that's based on, in this case, using a certain thickness and type of exterior insulation to meet that target. You're then going to select some exterior insulation based on vapor permeability. So you're going to choose permeable or impermeable insulation. Either works. And either will follow you through here. Then you're going to calculate an insulation ratio. And then this talks about that calculation there. It actually provides a number of tables for that. And then you're going to check other design criteria and run through the critical barriers of vapor, air, water, and cladding attachment. And then some examples here. So it's a 5-step process, and I'm going to walk you through this as a high-level summary. For further information, there are longer webinars available on the topic. Okay. So the first thing is where you are, and this is specifically put together for BC, but it also applies across the rest of Canada using 936. Depending on where you are in climate zone, you're going to have a minimum code requirement, and then if you're looking at step code or net zero ready, you're going to have a different target. But typically your target R value is going to come from an energy model when you're doing performance-based buildings. So net zero ready, the designer, the team, the energy modeler is going to say, I need an R35 or R40 wall. So that's your target, effective. Okay, so then you're going to go in and you're going to look and say, okay, with that R35 wall, I've got a number of different ways of doing this. I want to use R4 per inch or R5 per inch exterior insulation with batt framing. I'm going to need roughly, let's say 5 inches to get to R36, or 5 inches of mineral wool or EPS, or 4 inches of XPS. So you can sort of see in the table there, that would be your target. So you use this table to figure out the target, figure out the thickness of exterior insulation. Once you've sort of figured out a thickness of exterior insulation you need and type of insulation, you're going to now calculate the effective R value. You're going to use parallel path calculation in 936. You don't have to actually do the calculation here, but this is how it's done, where you've calculated the R value for all the pieces of the R value, including the framing factor, added in with the exterior insulation to figure out your overall R value. The next step is to choose your insulation or select the insulation based on the vapor permeance. Okay, and the way that this is category looked at is we got low vapor permeance insulation and high vapor permeance insulation. And the divider here is less than 1 US perm, or 60 nanograms per Pascal second meter squared, or more than 1 US perm, or more than 60 nanograms. So you've got low perm and then high perm insulation. Okay, and so in here you can see we got a table, if you don't know, and depends on thickness and the type of insulation. For example here, EPS. EPS at 1 inch thick is 5 perm. So we're going to put that on the high permeance side. If we have 5 inches or 6 inches, like we're going to see with the net zero ready wall, that becomes impermeable. Then we're going to follow the red side of the chart in the flow chart here. So we look at the table here, foam plastic insulations are the top 5 here, and they're all at thickness. The thicknesses we're usually talking about for net zero levels in that R35 to 40 range on a 2x6 wall, that's somewhere in the, generally impermeable. So, simplistically, foam plastic insulation can be looked at as low permeance from a simple standpoint, and things like fibrous insulation like mineral wool, wood fiber board, cellulose, rigid fiberglass, those tend to be vapor permeable. Okay, so you're going to follow the green or the right-hand side here. So we've got our target R value. We know we need, let's say, 5 inches of exterior insulation, and now we make the decision whether we use vapor open insulation or vapor closed. And so in the LEEP guides, we've covered both. And wall number 1 covers that high permeance vapor permeable insulation, and walls 2 and 3, and in 2 different methods of air and water control, covered that low permeance insulation. Okay, so we've selected our insulation based on permeance. We're then going to look at the insulation ratio. And the reason we're looking at the insulation ratio is we want to look at the outboard to cavity insulation ratio. And what this does, and if you run through the calculation here, what you're looking for here is you want to get enough exterior insulation that, or you want to look at how much exterior insulation you have. And if you can, get enough exterior insulation that you potentially don't need a vapor barrier on the inside. Or moreover, there are a couple of different ways to look at this. The question is, how much foam or impermeable insulation do I need to put on so I don't need a vapor barrier? Or with likewise with vapor permeable insulation, if I've got 6 inches of vapor permeable insulation, do I need a vapor barrier? Okay, so there's 2 ways of sort of looking at this. And generally, the higher the insulation ratio, the less vapor control you need on the inside. So the whole point of doing this calculation is to figure out where you're at. There's a minimum requirement, but there's also call it a building science requirement. And the building science is walked through here, talking about walls with and without vapor control, how they work, and how exterior insulation moves, increases the sheathing temperature, moves that dew point, so to speak, out of the assembly. And different types of insulation. So if you have impermeable insulation, you don't have outward drying. If you have permeable insulation, you do have that outward drying. And if you have that outward drying, then you can stop the vapor flow on the inside with little risk of that, having that wall without the ability to dry out, versus if you have impermeable exterior insulation, you tend to want to drop the vapor control on the inside or reduce it so you can allow some inward drying. And so it's all about allowing that wall assembly to dry out as much as possible. And so when you look at and follow through the building science discussion there, it then gets into some guidance. Okay, what ratio should I have, or what ratio would be safe for this wall assembly? Okay, so if we look here, we have this table here of ratio of outboard to total thermal resistance. And depending on where you are in Canada, you look at your average wintertime low temperature here. So if say 0 degrees, and then you got an indoor wintertime humidity, there's a bit of discussion there, but generally we're in the 30 to 50% realm, and depending on what you're designing for here. But let's just say, if you're designing 0 degrees, so in the coastal BC, 0 degree average at 50% humidity, it says I should have around 47% or 4.47 ratio on the outside to inside, outside to total. And that means that I should have 50-50, R20, R20. And that's, that's what a 50% ratio means. Likewise, if I'm in a colder region and I also have, the humidity is going to be a bit less in drier parts of the country, and especially when it's minus 20 or minus 30 outside, the humidity is just not going to be at 50%. It's going to be 30%, maybe below 20%. If you're humidifying the spaces, generally it's between 20 and 30%. And so you can see here, the colder it gets, generally the more exterior insulation you need. And so with exterior insulation, you may find that you might need up to 2/3 or 70 or 80% of the insulation on the outside before when you look at the vapor control on the inside. So depending on what this table tells you, that's the ideal ratio. If you don't have it, that's not a problem. If you do have it, it sets a different criteria. So you got your wall, you got your insulation, you figured out what permeance you have, you figured out your ratio here, and you're sort of following this through and you're writing things down. There's a few examples here, and generally, around 50%, 50-60% is going to be safe for most of Canada. The 2/3, 1/3 rule that many people have heard about in the past generally is a bit conservative, but it's a good sort of rule of thumb as well to be safe. So you now have your choice. You have your assembly. You either have a low ratio or a high ratio, and then you go through the charts here to assess what to do for vapor control on the inside, as well as air control. So you have either low ratio or high ratio. Both will work, and that's important to realize is both of these assemblies can work. There are slight differences to what the best strategies are to do for vapor control and also air barrier placement. So we get into the charts here. You got section 5, we got to look at vapor control. So the first thing with vapor control is we have low permeance insulation and then we have high permeance insulation. On the left-hand side, we have low permeance insulation with high ratios and low permeance insulation with low ratios. And the vapor flow control guidance is different. If you have a lot of exterior insulation, the exterior insulation is entirely controlling the vapor flow. If you have a little bit of insulation, you might not have enough insulation to warm that sheathing up enough, and that's what the ratio is looking at, and therefore you may need some vapor control on the inside. And that's entirely what this table is walking through. So I encourage you to sort of walk through some of your own examples here to look at high and low ratio. Both can work. And so there's likewise vapor permeable insulation guidance for high and low, and there's a number of specifics that come through this. So vapor control is covered. Air barrier and ideal air barrier placement is also covered in here. And then we also talk about different air barrier types, right? And if you're placing the air barrier on the inside or the outside, you have a lot of choice. And this talks about where the air barrier ideally would be in those assemblies as well. The third thing that gets looked at is water management. Okay, so water management, you've got your assembly, you've got the exterior insulation, you got some thickness of exterior insulation. Then what do I do for water control? What's the best thing I could do? Okay, and what's going to drive this is where you are. Are you in a wet region of the country? Are you in something with an area with a high moisture index? And if you're in an area with a high moisture index, you need to take a bit more conservative approach with your water management. In code currently, that would be things like rain screen designs and other details for water management and flashings. Versus in low regions where the risk of water penetration is much lower in drier parts of the country. And so there's two approaches. And this is where wall 3 and wall 2 get differentiated. So wall 2 generally recommended for low moisture index regions. Wall 3, with the details that we cover in the guide, generally recommended for the wetter regions. Okay, so you've got the two choices and you can use them. Then on the right-hand side, we got vapor permeable insulation. And so you got moisture tolerant insulation versus moisture sensitive. The key rule of thumb there is if it's moisture tolerant, things like mineral wool, then the water resistant barrier can be inside of it. If it's not moisture tolerant and sensitive, like things like wood fiber, then you need water control on the outside. Okay, and so that follows through into the flow chart there. And then it was talked about in the last part here. So we've got our insulation, we got the water air barrier placed, the vapor barrier, then how do we attach cladding? And so with thinner or thicker amounts of insulation, there's guidance here around that. And it talks about long screws through insulation and how you attach cladding to strapping that is screwed through your insulation for thicker amounts of insulation. A number of alternate configurations are also talked about. If you have, say, vertical board and batten or shingles, things like that, where you need horizontal strapping, how to do that. EIFS is talked about, and heavier claddings are also mentioned in here as well. So figured all the building science, got the cladding attachment worked out, and then it finishes off with a few examples for a few different cities and different assemblies to basically help you understand how to make any type of exterior insulation work with really any type of cladding, and then getting the right air and vapor control in behind that. And so it becomes almost seamless. And so this flow chart will help keep you out of trouble by looking at those ratios and looking at placement of water control, for example, with the impermeable exterior insulation.